Hello and welcome to my video on domain and range and the key features of these graphs. I'm going to review this do now. Please pause the video if you have not attempted the question. Give yourself a minute to fill in everything you do not understand between all these key features. Give yourself an opportunity to answer them for yourself and then watch the solution and correct your answers as we go. All right, so looking at the first one, it's asking us to state the key features of the graph. And so the domain we know is the list of all of the x numbers or the x values that our graph can be, but this is a continuous graph. So it does not have a list like 1, 2, 3, 4, like we would have if it was a discrete graph. What we have to do is think of what are all the possible x values that this graph can be. And so x goes this direction. So we're going to look basically like from here to here, where does the graph fit? So if I approach from the smallest side, the negatives, the first place that I touch the graph is here. And so that is where x is equal to negative 1, 2, 3, 4, 5, negative 5. If I go where the graph is the biggest, so on this side, and I come in from here, the first place that I touch the graph is right here. And that is where x is equal to 8, 9, 10. So our graph goes from where x is negative 5 up to where x is 10. So we use this interval notation that we talked about that looks like this. We start at negative 5 and we go to 10. But we have to put either square brackets or regular parentheses around this to show that it's the interval from this to this. And we have to decide, are we including the negative 5? Is that part of our domain? Are we including the 10? Is that part of our domain? So the way that we decide that is we look at the where the negative 5 is and see how this is a filled in dot. It's an actual point. This point is negative 5, negative 3. So since it's an actual point on the graph, I would include it, and therefore I would use the square bracket. If I look at the 10, and I'm not sure how well you can see this, so I'll zoom in a little bit here. If I look at the negative 10, see how there's like an empty circle there? So this little empty circle tells us that it's not really a point on this graph. The graph is going all the way up to where 10 is, but not actually getting to 10. So we wouldn't want to include 10 in our domain. Basically, the last point for x would be 9.99999 repeating forever. And so I can't really write that number because it's repeating forever. So I'm going to say it goes up to 10, but just before 10. So I get this regular parenthesis. And so that says start at negative 5, use every single number all the way up to 10, but don't use 10. And that use all the fractions, all the decimals, everything between negative 5 and 10. Looking at the range, it's the same idea, but I'm doing the range, which is my y's. So that's up and down. So the y-axis, I'm going to follow the y-axis. If I start at the bottom, the first place that I hit the graph is there. And that is where y is equal to negative 3. If I come from the top, the first place I touch the graph is here, this point, that empty point, remember? And that is where x is positive 3. Y is positive 3. So our graph is a much shorter range. It only goes from negative 3 to positive 3. So I use the same interval notation, negative 3 comma positive 3. It's including the negative 3 because I have a filled in dot here. And where it's 3 is that empty circle. So it'll be just like the other one. Let's start with a square bracket, end with a parenthesis. So that's interval notation for continuous graphs. We will look at interval notation again for this graph because it's also continuous, but let's finish what we have here. The next thing we need to do is look at the minimum. So what is the minimum point? Well, minimum is usually your lowest. So the minimum point is the lowest point on the graph, and so our graph dips the lowest here. And so this point is negative 5, negative 3. So that's what I would write here. Negative 5, negative 3. When the input is negative 5, the output is negative 3. Our maximum would be the highest point. So the highest point on our graph is this one, but because it's an empty circle, it's really not 10, 3. it would really be whatever comes right before 10, 3. So we're just going to write it that way, right before 10, 3. This is not a typical problem you would get, but just in case it comes up again, we'll write it that way. So it's basically whatever number is right before 10, 3, because it's not really, 10, 3 is not really the maximum, but it's 9.9999 repeating, comma 2.9999 repeating. All right, for intercepts, we look at all the x and y intercepts. So we look at the x-axis and where does our graph touch, and then we look at the y-axis and where does our graph touch. So if we're looking at the y-axis, I can see that it touches right here. That point is 0, 2. And then if I look across the x-axis, I see it touches here at 4, 0, and then also touches here again at negative 4, 0. So we have two x-intercepts. And then is this a function? So we can use that function test, the vertical line test, to see if we follow along this vertical line and I touch the graph all the way across, it's never going to touch the graph in more than one place at one time. It's always touching right along the line, touching once, touching once, touching once to the very end. Even here, it's like slowly coming down, so it's not really touching more than one place at a time. So this is a function because it passes our vertical line test. And I didn't ask you to explain here, so I'm just explaining so you know why. For the second one, we're looking at this continuous graph. The other main difference here is that this is a continuous graph with arrows on the end of it. So this has arrows on two ends of it, and we have to think about what does the domain look like here. So what is my lowest x? What is my highest x? If we think about the same way we did the domain before, we come in from the side. The first place I touch the graph is here, and that's an arrow. If I come in from this side, the first place I touch the graph is here, and that's also an arrow. So it really doesn't go from -2 to 4. It keeps going in the negative direction this way. So it's going, it's going up, but it's also going left. This way, it's all going to the right, and it's also going up. So we have to think about, what does that mean? What is the lowest negative number that we know? Well, our graph only goes to -4. This is going to keep going to -4, but then it's going to keep going. -5, -6, -7, forever and ever. It's going to go to negative infinity and beyond. So you never can get to the number. But the biggest number that we can write is negative infinity. That's what we call the largest or the smallest negative number. So we write that like this: negative infinity. And it goes from negative infinity in this direction, and it continues on in that direction too. So it's going to go to positive infinity in that direction. Because we can never get to infinity, we always go to infinity and beyond, we can't put those square brackets. So these get regular parentheses because you can never reach infinity. But it's the idea that it's going to go on forever in both directions. Looking at the range, looking at the y, coming up from the bottom, the first place I touch the graph is right here, and that is not an arrow. So -3 is our beginning of our graph. Then it's going to keep going, and if I come down from the top, where I touch the graph is here, and that's an arrow. So it's going to go past 4. It's going to go to 5, 6, 7, 8, 9, 10, and keep going forever to infinity. So our graph starts at -3, and it goes up forever in the positive direction towards infinity. So infinity can't be included, but -3 has a filled-in dot, so that will get included with a square bracket. Looking at our minimum, we're looking for the lowest point on our graph. So if we notice it's going up this way, it comes down, dips, and hits this point, and then goes back up again. So this is our lowest point. This is the point to -3. That's our minimum. Our maximum, it's going to go in both directions off to infinity, so it's never going to hit a top point. Like if I'm climbing this mountain, I'm never getting to the top. There's never a top to this mountain. It keeps going forever and ever. So there's no maximum here. So I'm going to write none, because it never hits the tallest part. For intercepts, I can see a y-intercept here of 0, 1. I actually have an x-intercept right here. Not a nice whole number, but it's directly between 0 and 1, so that's a half. So I have 0.5, 0 as that x-intercept. It's probably going to have another x-intercept when this keeps going over here somewhere, probably around like 7 or 8, but it's not on my graph and I can't predict that right now, so I'm not going to include that one. Is this a function? Does it follow our vertical line test? If I follow the graph, it's touching once, 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 hits this point. Now it's going to follow this line once, once, once. So this is a function. Passes that vertical line test. Now for the last one, if you notice, this one's very different. It's kind of like the first one. It's not curved at all. It has some flat spots. Has some dots that are filled in, and this one here that's empty. And then it has this little piece here. So it's not connected all the way through, but it's actually continuous. Because if you think about it, you're following the line up, you're following the line over. When I hit this one point that's not included, then it jumps down here. So if I think about my domain, I have to think about from the x point of view, the most left point is here. The most right point, if I come in from this side, is here. Is it including everything all the way through? Well, it is, because it's going from -3, following up here, -2, -1, going over this way. Now it's 0, now it's 1, now it's 2. Oh, it doesn't get all the way to 3, but it does have 3 here, and then 3 goes all the way up to 4. So it's actually going from -3 all the way to 4 for our domain. Are we including both of those? Well, -3 has a filled in dot. I'm not skipping this point really because 3 exists just down here, and then I'm going to there, which is a 4. So it's including the 4 because 4 is filled in, and it's including the -3 because that's filled in. And this one little place I thought was a hole actually gets covered by this point right there as far as the x's go. If I'm looking at the range, I'm going to be going from bottom to top. So the lowest I see is here. And if I follow up or come down from the top, however you want to do it, the highest part is there. So is our range going completely from -4 to 2? Well, this section right here is going all the way from -4 to 2. 2 is getting repeated a bunch of times in this part here. And then these, whatever these numbers are between -2 and -1, those are included over here. So it's got double inclusion. So it's actually continuous going from -4 all the way up to 2, and some of the numbers are going to get used more than once. So from -4 to 2, and -4 has a filled-in dot, 2 has a filled-in dot, it has a lot of points going along this way, whole numbers and decimals, so I'm going to include everything from one to the other. So not only does it have -4, -3, -2, -1, but it has all of the decimals in between from -4 to 2 as well. For our minimum, we look for our lowest point. Well, that's this one I have right here, which would be -3, -4. For my maximum, the highest point I have is here. It's actually a bunch of points. So I'm going to say multiple maximums maybe one is, and what is one of the points? We could pick any of the points on this line because that's as high as it goes. We could use this one, -1, 2. You could use this, 0, 2, 1, 2, 2, 2. We can't use 3, 2 because that's not really a point. You could pick some of the decimals in between if you wanted. But anything where it's ending in a 2 that is one of the points on this graph would work for our maximum. For intercepts, we have a y-intercept here at 0, 2. Do we have an x-intercept? We do right here. This one is a little harder to judge, but we can estimate. It's between -1 and -2, and it's more than halfway. So I'm going to say -1.75, comma 0. And those are the only two places where it's crossing the x or y axis. And then, is this a function? So if I follow the vertical line rule, vertical line test, if I'm following along, it's touching one place, one place, one place, one place, one place, still one place all the way across. Right here is where, I'm going to circle it, it would not pass the vertical line test, except for the fact that this is empty. And this one isn't. So if this was a point, 3, 2, you would have 3, 2, and 3, negative 1 sharing the same x. But this isn't actually a point, so that's fine. It will pass the vertical line test here. So yes, this is also a function. So I put that there to try to see if you understood what that meant. Hopefully you didn't get caught on that one. If you have any questions, please follow up with me. Thank you for watching, and hope you have a great day.